Today we're talking about position versus velocity versus acceleration. These are the three most common things used in kinematics for physics or calculus problems. A lot of people tend to confuse these three, especially when doing kinematics. So today's goal is to hopefully make it make sense to you guys. So first, let's define what each term is. So position in super basic terms is where you are located. And U is just, your object in the problem. So a simple example is if I have kind of a line here, so I have 1, 2, 3, 4, and I have a little person on 2, that person's position is located at 2. So position is usually written with like X, kind of denotes position. All right, let's go to velocity. Velocity is how fast and which direction you're moving. So how fast and which direction you're moving. So going back to this example, I have a guy on a line. Say my guy starts here and he is going to the right at 1 meter per second. So every second, this guy ends up at a new location. All right, and velocity is usually denoted by v. Acceleration is how my velocity is changing. I'm going to write direction here in parentheses because the direction of acceleration matters. So if I am moving to the right, I can draw better than that. If I am moving to the right and I start from rest, so I start from rest and then I start sprinting, the time it takes me from rest to running, that's my little running man. Right there, I had to accelerate. My speed changed, my velocity changed. And same thing can also go to me slowing down. So going from rest to running back to rest. So I can speed up, slow down, right? And that is your acceleration. And acceleration is usually denoted by the letter A. So one thing to note, position, velocity, and acceleration are linked. So one thing to note is that if velocity, v, is equal to, or is not equal to a constant, right? If velocity is changing, right, I'm either going faster, slowing down, my speed is changing, then I have acceleration. I have acceleration. But if my velocity is a constant, then I don't have acceleration. Right? So if I'm running at a constant rate, I am not speeding up or slowing down. If I am speeding up or slowing down, if my velocity is changing, then acceleration is present. So this is a quick way to know, do I have acceleration? Okay. Another thing to note is, sorry, this is just an example that we'll get to in a second. Velocity can be written as the change in position over change in time, right? So how far I move over a certain period of time. And acceleration can be written as the change in velocity over change in time. So how my speed changes over time. All right, so let's go ahead and get into a basic problem here. We have a car moves to the right at 10 meters per second at constant speed. What is the velocity and the acceleration of the car? All right, so we have the cars moving to the right. So remember, velocity from our definition is how fast and which direction. So we know our velocity is 10 meters per second. That's how fast. And our direction is to the right. So that is our velocity. If, so this is important. If I would have said v is equal to 10 meters per second, and I would not write this, and I just left it at 10 meters per second, this is my speed. So speed is just how fast something moves, or slow. I'm going to say how fast or slow something moves. And velocity is just speed with direction. So if I would have left the answer as just this, that would have been my speed. But it specifically asked for my velocity, so I have to say it moves 10 meters per second to the right. So this right here is my velocity. Now, acceleration, we have that the car moves at a constant speed. And as we just said, if v is constant, then I don't have acceleration. So my acceleration is 0 for this problem. And that's it. Hopefully that made sense. All right, let's move on to a different problem. So here we have a car. We have two options. We have a car with the velocity and acceleration arrow pointing to the right, and then option B, the velocity is pointing to the right, acceleration is pointing to the left. And I want to know, what is the car doing in both pictures. So go ahead, pause the video, try it on your own, and then we'll come back and we'll do it together. All right, let's get into it. So for car A, we have the velocity is going to the right and the acceleration is going to the right. So what this means is I am speeding up to the right. Right? So you can see the car is moving to the right, moving because velocity points to the right, and acceleration points to the right. So it is speeding up. It is gaining speed. The velocity is increasing as it's going to the right. And car B is the car is slowing down. So as you can see, the car's motion, it is moving to the right, because remember, velocity is speed and the direction of which you're moving, while the acceleration is to the left, which means the change of velocity decreases over time, which means your speed decreases over time. So hence you are slowing down. So key thing to note, velocity points with motion, right? So in both of these cases, the car was moving to the right, and we figured that out because of the v. While acceleration, and I'm writing this arrow on top to dictate that it has both direction and magnitude, does not always point into motion. So acceleration doesn't always point with motion. point with motion. All right, so hopefully that kind of makes sense. Again, velocity is where you're going. Acceleration is how fast you are accelerating or how fast you are slowing down. All right, so we're going to do one more problem. We have a car starts from rest and accelerates at 2 meters per second squared for 5 seconds. What is the final displacement of, what is the final velocity and the displacement of the car? So go ahead, pause the videos, try to do it on your own. If you need to pull up your formula sheet, now would be the time to do so. All right, hopefully you had some time to work out the problem. Let's get right into it. So first things first, let's write out our known variables. So we know that the car starts from rest. So this means that our initial velocity is 0. We have acceleration at 2 meters per second squared. So acceleration is 2 meters per second squared. And this is, I'm going to say meters per second. Well, then we have our time, so we know that it moves for a total of 5 seconds. So our time is 5. All right, so we want to find velocity. So one thing I like to tell my students in physics is that physics is just a big scavenger hunt. Look at what you have, what variables you're given. Look at what you want to find. So we want to find v final and we want to find displacement. So displacement is another word for your position, your x. Um, and then look through your formula sheet how you can connect from your starting to your end points. So I'm going to use the formula v final is equal to v initial plus a t. So this is on my physics 1 formula sheet. And I have VO, A, and T given, and I'm looking for VF, so this is perfect. So now I'm just going to plug everything in. So I have VF is equal to 0 plus 2 times 5. V final is equal to 10 meters per second. And notice how in this case, I don't know which direction it is going. Right, left, up, down, doesn't matter. So technically, this could be a speed. However, if we are not given a coordinate system, leaving your velocity like this is perfectly fine. If we were given a coordinate system, right? So if we had something like this, then we would have to say which direction, in the x or y direction does this go. But because we don't have this, this right here is perfectly acceptable. All right, let's move on to finding the displacement. So again, go to your formula sheet, see what we are given and what we are trying to find. So I'm going to use the formula x is equal to v naught or v0 times t plus 1 half a t squared, right? Because I have all these variables, or I was able to figure out all of those variables to find x. So same thing, I'm going to plug it in. So this is equal to 0 plus 1 half times 2 times 5 squared. And this simplifies down to x is equal to 25 meters. So after 5 seconds, my total distance traveled is 25 meters. And there you go. Hopefully that helps you with position, velocity, and acceleration. And I'll see you next time.